to get a feel, how many of you all in the room write unit tests or some form of tests regularly, like every day or every week? If you want to write a job. Awesome. Good. This is a good group then. So, yeah, I mean, unfortunately, a lot of web developers maybe skip this or don't get to because there's not time. But I'm a huge advocate for testing. I am right now the CTO at a company called the Great Network. We hook K-12 teachers up with college students to grade papers for them. And that's cool. It tech's fun. I've been working on it the last 6 years. So if any of you want to talk about that, happy to afterwards. But today we're going to talk about distributed systems and testing. So if you're not familiar with the idea of a distributed system, this is Leslie Lamport's a researcher in distributed systems, kind of invented a lot of the modern theory in the field, and I'm not an expert at this at all, but I love this quote anyway. He says that the distributed system is one in which the failure of a computer you didn't know existed can render your own computer useless. So we see this a lot in web development. Typically we're building stuff where we've got a front end that's separated from a back end, and there may be APIs, one or more or many, powering that front end. And when one of them goes down, if we didn't build things right, it takes the whole system or a large part of the system down. That's something we want to avoid typically. So this is part of the reason that testing these kinds of distributed systems is really important. I kind of have 5 reasons I've picked out here. You could probably pick out another half dozen if you really wanted to dig deep, but sort of the top one to keep in mind. So when we're building distributed systems, we want to keep in mind that fault tolerance is really important. So that whole Leslie Lamport quote is just going back to that. If something goes down, how's the whole system going to respond? The next reason I think testing distributed systems is really important is because you can't control how other services that you rely on use things like semantic version. So how many of you use an API that is unversioned as far as you can tell? I have a few that I rely on. They're not in my control. Got no power over how it works, how they do updates, right? So testing can help alleviate or at least minimize the risk of relying on that sort of API. And that includes, I guess, your internal services as well. I mean, you may have a large team that's distributed, and you may all be working on things, updating them. Similarly, network connections are never perfect. I think server to server in the same data center has gotten pretty good. I mean, I can usually rely on that sort of connection pretty well, but my server to your front end, I really can't rely on that network connection at all. So testing helps us prevent any issues with that or losing them. And then this is kind of tangentially related to distributed systems, but because we're building distributed systems and a lot of open source software, we tend to import a lot of packages. I'm going to assume everyone here is familiar with Node Package Manager. Yeah, got that. So that's something we use in JavaScript, but there's every other language has got its own version of Package Manager, and we are usually going to be pulling in some packages for almost every project. And then finally, when working with siloed teams, so distributed systems tend to lend themselves well to siloed teams. What I mean by that is if we've got 5 APIs that our front end or our clients rely on, we may have 5 different teams. One of them may be in charge of each API. This is kind of the Amazon or network model of microservices. But a lot of smaller companies adapt the same thing. And the challenge there is that we want to make sure that when people leave one team to join another, or let's say they're a new person on a team, they can quickly be onboarded and know how things work. And testing is a great supplement to documentation. So that's why we want to test distributed systems. And then for the rest of this talk, what I'm going to go over is kind of the introduction to the terminology used in writing these kinds of tests, using those tests in practice, and then we'll go through creating an actual test plan. So there's 4 layers of tests that I'm going to talk about here today. I'm not going to get into things like performance testing. I'm not going to get into anything like load testing, although those are really interesting topics as well. But since this is just sort of a short talk, I don't want to run into everything you could possibly cover. So the first layer is unit tests. How many people write unit tests all the time, and you only write unit tests as far as you know? A couple people? Okay, cool. So it's interesting, though, looking up the definitions of all these kinds of tests, because a lot of people define unit tests as any kind of automated test almost. I would typically, though, define a unit test as something that tests the smallest unit of code possible, typically that's a class or a function. So I'm writing a very limited sort of spin on what a unit test is. And I would typically say that a unit test needs to mock any external dependencies that it has. So for example, if your unit test is going to be writing files signals to the file system. You want to mock that file system down. The thing that's nice about unit tests is you can write a ton of them for really cheaply, and they can run really quickly because you're mocking everything that's like really doing file system I/O. So it's really easy to write a lot of them, and if you look at things like the test pyramid, is anybody familiar with that diagram? It's called like a testing pyramid, and it kind of like starts to got a top that's really small and it's larger, like most pyramids. So with that, unit tests on the bottom. And the reason for that is that you write most of them, they're kind of like the core foundation. So really important. The next layer up in these testing layers that I talked about for distributed systems is integration tests. And with integration tests, what we're trying to validate is that groups or a couple components that we have work together in tandem well. There's a couple reasons that integration tests are useful. And one is if you have like a legacy system you inherited where you don't get control over how they did dependency injection, and so there's no good way to test things in isolation, you can pretty usually get some kind of integration test in that will like test several pieces of the system together. That's better than nothing. The other reason I like integration tests are things like testing boundaries between services. And we'll get into this in more detail, but for example, let's say I want to test the way that my model, ORM, and database interact. Because typically I'm going to import an ORM that gives me some form of model that I'm going to use sort of like expecting it to work. But the reality is I want to make sure that that works. Even though I may trust my third-party packages that I'm using or whatever ORM internally we've built, I really want to make sure that I'm actually getting the data, that the filters are being applied as we expect. So integration tests could be really helpful there. The next layer up is acceptance tests. So we're talking about distributed systems here. So we're talking about several services, maybe several client layers. An acceptance test will typically wrap one whole service or one whole client layer. Maybe it's a front-end application like an Angular app, or it's a front-end mobile app or whatever. But we want to mock all the external dependencies for an acceptance test. And then finally, the last layer is sort of the big one. And this is end-to-end tests, which are essentially analogous to click tests. So if you're not writing automated tests, this might be the only kind of test you run. They might be fully manual. And I've worked on games where that was unfortunately the situation, and that can be tricky, but it's doable, and if you have to, you can do it. Even if you are writing a fully automated test plan and you've got all the tools in place, end-to-end tests are really helpful because even though you may be testing each layer along the way, just ensuring that all the pieces of the system actually work as a whole on a regular basis adds a lot of security to sort of knowing, or just, I guess, gives you a lot of internal security, feeling like you know that things work. For end-to-end tests, I typically would try to use real data sources as much as possible. That means actually hitting third-party APIs when I can. And occasionally when a service doesn't allow that sort of thing, I will mock it. So those are the definitions. I've pulled a lot of the sort of base of those definitions from this really good presentation that Martin Fowler has out there. You can look at Martin Fowler testing microservices, and he goes into more depth about each of those layers and how he uses them. But let's talk about how we would use these to test something that we're probably all familiar with. How many people in here build something on an MVC style architecture? So model view controller. It's kind of like one of those, I don't know, web developer 101 things that everybody gets to do the basic tutorials. You've done the tutorial of Rails, and it walks you through what all those pieces mean. So it's a good place to start with testing. So let's say we've got a simple MVC monolith all on one server. For the sake of this example, we're just all on one instance, so we're not even worried about duplication, we're not worried about load balancing. Let's keep it real simple. This might be the way we would set up our test for it. So we might test models, controllers, and the router. We would have unit tests around them. Those are going to test each method to make sure that internally all the business logic or whatever logic we've got in there works well. We would also have some integration tests. Typically, the area where I see the most use out of an integration test in something as simple would be between the model and the database. And what that's going to do is allow me to say that I have a user's model, and I know it's connected to a post model. If I want to say, get me users with posts, I want to ensure that the data that comes back is formatted correctly. Even though we're relying on the ORM, it's supposed to work. Let's just check the whole thing in the integration test to ensure it. The next layer up is the acceptance test, which for this, I would typically try to mock the database in some way, and that may be injecting some kind of sort of a mock version of your ORM or whatever the model itself. And then I would test all the way to the view to make sure that the data that comes through on the front end is what I expect. And then the last layer, the sort of biggest layer, is testing the whole thing end to end. Cool, so I'll take a break for just a second on this. Yeah. So, yeah, it kind of depends on how the view is rendered. So if it's rendered all in the back end, I probably wouldn't because I would take care of any of those sort of cases with the acceptance test. But I know a lot of people, when they've got a full single page app, you would obviously want to unit test as many of your sort of layers as you can there. So I haven't personally done a lot of view unit testing, but you can do it, and some people do. So they may do unit tests on their views themselves.
Very static one.
No, okay.
So the
Yeah, I don't need to verify that my property.
Yeah, I mean, testing to where you're going with that is testing is all about pragmatism, right? Like at the end of the day, if it adds business value, which tests do, then great, you should do them. When they start to get like lots of times I won't test my routers either because it's not business logic. It's just a pass through to the controller, and all it is just some strings. So if those strings get done wrong, hopefully an acceptance or end-to-end test will catch that, and I shouldn't have to unit test it. But in some cases, maybe I did. So I put it on you. Any other questions on this real quick? Okay, cool. I'll keep moving. So let's get real. We never get to build things that simple. At least once you get out of like tutorial 101 mode, things get real complicated real fast. And it's also fun. So some things you may deal with in a distributed system. We're going to have multiple repositories where code is stored. Maybe they're stored in completely different organizations, whatever. We've got a bunch of servers or a bunch of containers across a bunch of servers. We've got shared packages we're importing. We have internally built shared packages, all this good stuff. So let's look at a sort of, this is still a pretty simple distributed system, but this is a more distributed system. What we've got here is a front-end application. Let's say it's like an Angular React application that relies on two back-end microservices, which each connect to a database and some third-party APIs, and then they both import some internal package and maybe an open source package or two as well. This is kind of like dullity on this kind of architecture, sort of makes sense. This simplified diagram to show how it all works. So let's go through the process of how we might make a plan to test this sort of thing. And we're basically just going to first worry about one pathway at a time. So in practice, you're working very much in each of these little segments, but I think it's good to take a step back and look at the high level. So let's isolate each pathway, break it down into layers, much like we did with the MVC architecture, and then for each layer or each service, we're going to test internal functionality and external functionality, or connection. All right, so how do we isolate a pathway in this sort of system? I'm going to sort of take some liberties and say that this is just a single pathway that goes from the front end, gets all my users from the database, it merges in some data from a third-party service, and then displays them out to an admin or whatever.
Yeah, when you say pathway, you sort of go to like a use case, or you go
Yeah.
like a specific split?
Yeah, so let's say that this is more of like I'm the admin, I render one view, and that's what view like 10 views, something like that. So whatever, I guess it's one functional unit of code. So at the end of the day, what we care about is what's rendered to the user, but behind the scenes there's all this stuff going on. We need to think about that. So here's like a more, I guess a more linear version of that same pathway, just to kind of break it down into how data goes from uphill to downhill, or downhill to uphill, depending on how you want to say it. And then let's look at each of the layers inside of each of those services. So we'll dig into these in detail, but we've basically got three main services that we want to test. We've got our front-end application, a back-end application, and a shared package. So let's start back with our internal packages. So if our internal package, all it is let's say an HTTP client we wrote to connect to some third-party API, then it's just simple. It may be simple. It may just be one class that has some helper methods that wrap whatever knows HTTP calls, and then it's going to go back to the third-party API, get some data, maybe format it nicely, and then present it out to whoever requested it. Unit tests are obviously important if there's a lot of business logic in that actual HTTP client we wrote. You may or may not feel the need to do that depending on if it's just a pass-through or not. But for a unit test, you want to mock all that back-end API data that came through. And then the other piece of this that I think is important is the integration between the HTTP client and the actual third-party service. So with integration tests here, I would typically use the actual call, like action calls to that third-party service so that we could get real data from them and see how it works. This is where we can catch breaking changes in their API before they hit all of our users. So we can run this kind of test, this integration test on our package, because it's probably a pretty lightweight set of tests. We'll run it every hour, every month, every week, whatever we think is necessary, depending on the criticality of our system and all that good stuff. But yeah, that's the kind of thing I would just automate to set up to run all the time. And whenever that fails, if I have an integration test failure between my HTTP client and third-party service, it's telling me that something went down outside of our system, but it could take down a lot of things. Another thing that's important to talk about here is when doing these unit tests on the HTTP client, test the unhappy cases. So I think one of my bosses one time kind of teaching me a lot about testing, and he said, before you write any of the happy cases, which means the success case where everything goes through into 200, I think the status message, test all the error codes that you could get or all the bad responses from the API, and make sure that your unit tests cover those as well. And I think those are actually more important a lot of times than the happy case, which is, it's kind of the gimme, it's the easy one. Then we kind of move up the chain. We've got the back-end API that we built, and it's relying on this internal package and the database connection. And so we're going to do the same thing we kind of did with the MVC. We're going to unit test the controller, the router, maybe the model, depending on how much logic we have living in there. And then integration test that connection between the database and the model to get our ORM, make sure we've got all that going right. And then do an integration test on the connection between either our controller or model, whichever one connects to the or imports the internal package and makes those calls back. So for this integration test, I would typically try to mock that third-party API because our goal here is to test that our backend service actually imports this internal package as we expect and uses it correctly. The previous test, this one wants to test whether that third-party service is giving us the data we expect. And then moving up to the front end, once again, we want to integration test the sort of connection between the front end and the back end, so make an actual call to an instance of our back end service if we can. This is where things like having some kind of container-based build system really helps because you can spin those up really quickly. And if not, then you can, another way I've done this before when we had to was just have a whole testing environment with all of our services kind of like running all the time. And then we would just call that as our sort of back end. So that's another way you can do it if you need to. And then unit test each of the layers. For this, I'm kind of using the Angular 2.4 method of architecture. So it's like this data stores, RxJS store, and components. But whatever your layers are in your front-end application, same thing. And then we acceptance test the whole thing while mocking the backend service. So this is like the whole kit and caboodle together. And then we finally, like the only thing I've added here is let's end-to-end test everything that we can. End-to-end tests they seem like they would be really great because you could just catch anything that goes wrong ever, right? But if you ever tried to maintain an end-to-end test suite that's really comprehensive, you know how expensive in time that can be. A tool that I've come to love lately is called Ghost Inspector because it actually will let you do like record quick tests on your screen, and so like your junior devs and QA people can do that without a lot of developer support. Just go to 10. But a lot of people use things like Selenium, which is really good for this sort of end-to-end tests as well. All right, so let's just kind of do a quick look at how those layers fit together again, and then I'll get off stage and we'll keep moving on. So first of all, unit test, we're trying to get each one of our services tested in isolation, the smallest unit of code we can tested inside of them. With integration tests, we're really focused on the layers between the services or between services and backends that go behind them. And then with the acceptance test, we're trying to ensure that each application or each service, whichever it is, works in tandem without the external connections. And then our end-to-end tests are kind of trying to test the whole thing in conjunction with everything else. Awesome. So I really appreciate your time. Thank you so much. And if you want to see this again, I'll be giving this at API Straps conference that Linux Foundation puts on in Portland. And does anyone have any questions? Anything else I can answer? Yes, sir.
I thought you were going to run an example, like a short example.
Yeah, so that's pretty much what we've got with all this. I don't have any code examples today. Yeah, sorry. I had that. Did you see this last time at the Angular meetup?
It's a lot different.
It was. This has undergone many iterations.
This is a lot better.
Okay, thank you. Yeah. So when I think that all these terms, first of all, are like pick the terms you like, and if your whole team agrees on it, that's fine. Like unfortunately, there's not a consensus on what these terms are. So this is not just me being weird. This is like I've listened to 3 or 4 different podcasts on this topic, and every one of them, the guy's got some other term. So, but for me, the distinction is integration tests are typically trying to test 1 or 2 classes together that are closely linked, or 1 or 2 like pieces of a system together that are closely linked. Whereas an acceptance test is just trying to test one whole system in isolation. So it's like you take that one microservice without any back-end connections that it relies on, and just test if it works. But then we also want to test that at the integration level that it works with the things it's integrated with. If that kind of adds a clarity.
Like the units, like larger, like units versus like how
Yeah.
how they talk to each other.
Exactly. Yeah, that's the way I try to define the difference. And this kind of comes down to if your team is doing a highly distributed architecture, then you need some common language for what those tests mean that are testing these links, right? So we call these integration tests. And acceptance tests are more just like, let's test this one service with the packages it has, but not worry about how it connects to the database and the third party. Yes, sir.
Well, how do we effectively go from a integration type of a test to a unit test? So in essence, you pretty much stick together, something that works on an item, and then kind of realize that you want to clean this code up, you're going to read some classes out of it, and now you pretty much you can read the test if you create it. It's going to work because it doesn't factor it. But it runs from a unit test into integration test. So now, what is the best way to cut down on the wasted time to basically either reimagine the testing or how do you handle that?
Yeah, that's a good question. So I would sort of turn that around and ask, do you need to change? If your test is green, you refactor and your test is still green, you need to change that test. Did it lose something?
No, and actually that would be a very, very cool way to do it.
Yeah.
You pretty much leave it and it works, right?
Yeah.
But then again, you expect one project to be unit test and it turns into integration test.
Yeah.
So now, granted, you can kind of decide that if once you're going to start partitioning it off, and then you can actually refactor the test themselves. But in real life, how do you guys deal with it?
How do I deal with it? Yeah, so to me it would depend on if there's a lot of added value by breaking that, what became an integration test down into unit tests as well, or if it accomplishes all the goals that I think it needs to without doing it. Building a test plan is great, but the real world is always a little more complicated. So I think the way I've always approached it is to write a test plan along with my initial sort of ideal architecture up front, so I have some idea where I'm heading. But the reality is we take a lot of steps to get there, and those steps aren't continuous, and sometimes we leap over a whole layer of tests that we didn't need or realize that aren't adding that much value. So I don't have an exact answer. I think it's always like weighing off those trade-offs of how important is this, if this really works, and that how much value does that new test or whatever add to the system. So that's kind of the equation that I have in my mind. Does anybody else have a better way they handle that? I'm very open to suggestions.
Okay, well, the next one is,
yes.
So how do you actually name those test suites? So to reflect this value-oriented choice of implementation of the test.
Yeah, I haven't encountered that exact situation where I was going from like a unit to an integration test like that. But I think I would try to rename it if I could, and if not, I would maybe write a note on it that said, yeah, this is still called a unit test, but it's kind of an integration test.
I mean,
I don't know.
from what I gather, is some people expect to basically write a training test,
Yeah.
there's an integration test, and then you cannot imagine how it's supposed to be solved, and then you basically progress to the unit test all the way through. The problem is that you're going to go from the acceptance test to integration test to unit test, and now you have to remember 3 layers of the way that you can
Yeah.
envision the solution is going to,
Yep.
materialize, and that's quite a lot to
It
do.
is. It is, and I think that using all of these layers in any one application or one pathway of an application is probably towards the high end of testing. Like it's more testing than a lot of applications need, because a lot of times some of these layers are going to be just pass-throughs, right? Like, I may have a model or a controller that really doesn't do much logic-wise. It just calls a model method that I know works. So in that case, do I need to unit test everything in that controller? Maybe not. So I've always been very pragmatic about if we're not doing any logic and it doesn't add value, then I don't see the need to add a test there just because we normally do a test there. It just seems a little blindly following.
I mean, coverage tool can help you with the highlights your switches and if statements.
Yep.
They basically have a one line without no logic. You want to highlight it, right?
Yeah.
As long
Exactly.
as long as you call the method, it will be fine.
Yeah. So, and then you hope that if you've built a couple other layers beyond that, like an integration test or an acceptance test over it, that it's sort of going to catch some of those major naming errors or something, or your IDE will catch it.
So how do you organize your test file? Do you keep them in the same directory as say your controller and your test controller?
Yeah. So
or you do a separate folder?
I've normally done it it's got its own separate folder at the root where it's testing, and then you've got a folder for unit test, folder for integration, folder for acceptance, and then it kind of follows the same pattern as the application does.
Yeah.
But then lately, I've been using Angular 4, and that's they want you to have the tests in there with the components and with the services. And so I'm not opposed to that view. I think I'm still getting used to it, and I don't prefer it necessarily, but I'm playing by the rules.
I think maybe Angular 4, because it's basically all the tests on front end should be unit tests. You're not going to really run integration or anything.
Right.
It's all unit. That's why it can run fast. You can put it in the same folder.
Yeah, and you can run integration tests. I actually do quite a bit of integration tests between components and directives, or components and pipes.
Yeah, but you don't hit external, so you're not doing, you're not hitting actual APIs from front end. So
it's
they will
less
run
likely.
fast. They will run fast.
Yeah, agreed. Yeah.
What would you consider prop types in React?
Prop types?
Yeah.
Ooh, I don't know much about React.
Okay.
Anybody know what a prop type in React is?
It's checking for the React.
Oh, okay. So
whether you're passing this string to the string or not.
Yeah.
It's like type checking for your parameter. You can think of it, but you can use more than that. It is an external add-on for you.
I'm a really big fan of TypeScript with Angular 4 just because of the type checking, the strongly typed stuff. This is kind of my first time working heavily in a strongly typed language like that. And so I don't think it eliminates the need for tests. I think there's a big talk about strongly typed versus unit tests, and they're mutually exclusive, but they're not. They're just a different thing. They can help for sure, but they're not going to replace checking over logic and loops and things like that you need to unit test. So. Yes.
While we're taking the
Yeah.
content, maybe you can switch.
Yeah.
So you can still continue.
Yeah, thank you all so much.